So Zcash started in development a few years ago, building off of a fork of Bitcoin and adding advanced cryptography to provide privacy for users of the network for their transactions. So while in development for the past few years, we've launched the open cryptocurrency late last year, October 28th, just over 6 months ago. And it has been growing ever since in terms of usage and nodes in the network. So our main goal was to create internet money, and we felt that there was a lack of essential properties for internet money in a lot of the existing cryptocurrencies, namely fungibility, so the property where assets can be interchanged with each other and not discriminated against based on things like history, where they who has owned them in the past, and also financial confidentiality. So this is just the basic concept of user privacy. And in order to add these attributes to a fork of Bitcoin, we're using advanced cryptography called zero-knowledge proofs. And more specifically, the implementation we're using is ZK-SNARKs, which stands for zero-knowledge, succinct, non-interactive arguments of knowledge. And that essentially allows the protocol to encrypt transaction data while still being verifiable by the nodes in the network. So you can kind of consider a problem with using a public ledger blockchain, and for those transactions on that blockchain to be verified by nodes in the network, they need to sort of they need to know that, for example, the owner of the token actually owns it, that it hasn't been previously spent to an address previously, and that they actually control that account, so have the private key. So using zero-knowledge proofs, which more information is available on our website about, there's a lot of deep technological backgrounds, and we have a really good overview on our website that people can learn more about. But that's essentially how we're adding this fungibility and financial confidentiality into a blockchain. And one really great aspect of just encryption as a whole is being able to selectively disclose the contents of the transactions to any third party. So not only is the content encrypted on the blockchain so that only the sender and receiver know the data, but it's also very simple to create a separate key that you can give to any third party so that they can see that content as well. And that can be particularly useful for things like tax reporting or just like general business processes where you want to disclose transactions to some people but not the whole world. So to kind of illustrate these concepts, I have two diagrams. On the left is Bitcoin as a spreadsheet. So you can sort of see, perhaps you can see, hopefully, there's address A and address B on the first line, designated to a block, and address A sends B 3 Bitcoin, and then later on in the history, address B sends address C 2 Bitcoin, and so on. And with that public ledger, you're able to link those transactions together fairly trivially. Basically anyone observing the network or the blockchain. And with Zcash, all of those fields are encrypted using the zero-knowledge proof, so sender, recipients, and balance are not publicly visible by the public on, even though it is a public blockchain, those details are not revealed because there's the addition of the zero-knowledge proof. And also, Not listed here, there's also, when sending a private payment, an option to include an encrypted memo field, which can be particularly useful for things like you go to purchase something and you might want to include a refund address that is private to you, the sender, and the merchant, in the off chance that you want to return the product or have some money sent back to you. And in terms of the selective disclosure, you can sort of imagine that one of these lines is revealed to, say, your local tax agents for reporting your expenditures, or in the merchant's case, their income. And further, a little bit more about just general policy and parameters in Zcash. So we are a fork of Bitcoin, as I mentioned. We forked from 0.11.2, which is a little while ago, and we're kind of cherry picking upgrades that the Bitcoin core team has been including in more recent versions. We're not, upgrading every single thing. We're being selective about what we're going to include. And because we also forked off of Bitcoin, we are able to have two types of addresses, one being being transparent addresses, and one being shielded addresses. Shielded addresses use these zero-knowledge proofs to encrypt transaction data, whereas transparent addresses basically act like Bitcoin. So the data about the transaction is public on the blockchain. And this is, including transparent addresses, is really mainly about easing into this new ecosystem of Zcash and making third-party developers and other services, giving them a really easy way to implement Zcash. So this is kind of level one of third-party support that we see it as. And then if, when the time comes, when the third-party merchant is ready, they can also include the shielded transactions. However, it just takes a little bit more effort, but it's totally worth it, and especially to be able to provide your users with the privacy that Zcash set out to solve and to provide for in this internet money system. So, and also you can send transactions between transparent and shielded addresses. There's some kind of complexity surrounding the linkability of transactions in that regard. However, actually, if we go back to the previous slide, you can see that there's no linkability in the Zcash as a spreadsheet example, whereas all of these Bitcoin transactions, the addresses used are linkable. That would kind of hold true in some cases for transparent addresses. However, if you can imagine that one of these lines is encrypted, or if we're going with the Zcash, one of those lines is like the Bitcoin spreadsheet, you can sort of see that there's still a really there's good protection against linkability of transactions in the network. So there's still an improvement if you're just using the transparent addresses in Zcash, which some mobile wallets only support right now. But hopefully one day we can just only have shielded addresses. That's the end goal. And just some other parameters, we use an equihash proof of work, which is memory hard, essentially attempting to prevent ASIC production for miners. We have a 150-second block time, which is 2.5 minutes, 2 megabyte blocks, 12.5 Zcash distribution for a block reward, and a 4-year halving. And for the first 4 years of the Zcash existence, there is a founder's reward fund, which takes 2.5 of those 12.5 Zcash and puts them into a fund to pay previous investors, kind of more short-term development. So paying the making sure that the Zcash company has funds to keep going without having to take any additional investments, and then also long-term kind of outlook for maintaining the Zcash protocol in the future. We are in the process of setting up a Zcash Foundation, which hopefully the plan is one day, once that's really going and ready to take on a lot of responsibility, we can hand over the open cryptocurrency development over to the foundation, and they can kind of maintain that going forward, where the company can sort of divert its focus to perhaps more of the enterprise solutions and other things. So there's a lot of more information on our website, z.cash. We have Twitter, Zcash Co., and we have a really awesome community that can be, there's kind of two main places that they hang out. Our forum that we host at forum.z.cash, and a community-hosted chat room, chat.z-zcashcommunity.com, and of course, our source code is open and available at github.com/Zcash. So we highly encourage people to get involved. There's so much opportunity for developers and just people that want privacy for their transactions. So please reach out to us, and thanks.